So let's try to simulate typical motor control, basic. This one. Okay, in this video, this is a 3-phase DOL starter control overload indicator power wiring diagram. So ito yung main breaker. This is the main breaker, the contactors and the contactor and the overload. So DOL means direct online starter. Okay, let's go. Okay, given these components of electrical starter motor control, so this one is the breaker control. This is no switch for on. No, this is NO, normally open switch, and this one is NC, switch for off. So this red button is for switch off or for stop, and this green button is normally open, and then this is to switch on the contactor. Given these components, we will try to simulate using our downloaded software from the internet. So this is Ekts. Let's try if this circuit will work. Okay, this is the free software we have downloaded in the internet. This name is Ekts, Electric Commanda Technically Readercy Simulator, Electric Control Technique Simulator. Okay, let's go back to our diagram. let's finish watching this video. Three pilot lights: trip, stop, run. When we press the green button, push button, it will signal this light running, and then when we press this, it will signal stop. Then when the overload the trip yellow pilot light will lit. Okay, this one is the contactor, and this one is the overload relay. We have normally open, normally close, and auxiliary contact. This one is the stop and the reset button. So when this stop trip, so there will be a problem on the motor side or the load side. Notice that on this contactor there's numbering. 13 normally open, 14 normally open, 21, 22 normally close. This one, A1 and A2 is the supply of the coil of that particular contactor. Oh, our Ethernet lags. Okay, let's given this diagram, we will simulate on our software. This is the three-phase supply, contactor, overload. This one is the three-phase motor, push button, stop button. Okay. This is the main control of control breaker of that controller. Okay. Let's move here. So from here, we have AC power, so we will put three-phase power. This is the three-phase power, and then let's put neutral for the controller. Okay. Then we have a 3-phase induction motor. This is the motor. This one. Then we'll put components. What is the components? Start push button. This is the start push button, and then this is the stop push button. Then we will put contactor. This one. This is the contactor. Then lamps, which is the pilot light. We have 3 pilot light. Sometimes it's boring, sometimes it's not. Right. We will not put a timer. There's no timer on the example diagram. So we'll put a normally open contact. Okay, this one is the normally open, and then we have to put another normally close contact. Okay, system. Okay, since in this library no breaker, we will just direct the supply to the motor, assuming that we have installed a breaker. Okay, so this one, let's put a label. This is the start push button. This is the stop push button, and then this is the motor contactor. Assuming that on this contactor there's a built-in already connected overload relay, since we have no overload relay on these components. Okay, so this is motor contactor. Let's provide MC. This is run light. This one is the stop light. This one is the trip light. Okay, given this diagram, we can now connect following this connection from the 3-phase breaker, going to contactor, going to motors. So we forgot the 3-phase connection, normally open 3-phase connection. Normally open, this one. This one is the open contact of the contactor. So we try to rotate it 90 degree, assuming this is the 3-phase contactor, and this is the 3-phase motor, and this is the, what is this, normally open contact of this contactor, this one. So let's connect. From here, the RST, or the line 1, line 2, line 3, we will connect this, assuming that we have a breaker here. So this is the 3-phase supply of the motor. Okay. Okay. Since we already connected this three-phase wire, three-phase supply, going to contactor, going to motor. So this is that. Now we will proceed to the controller. This side is the power circuit, and this side is the control circuit. Okay. Let's proceed here, this part, the control circuit. Okay. We have a start, so this is start push button is series on the stop, and then series on the contactor supply, and then the other one is connected on the neutral, or the line 1 or the line 2. It's either, but our control circuit is only a single phase. And then the other side is connected on the other supply line, let's say the line 3 or the line 1 and the neutral. So since this is start push button, when we press, it will come back into normally open, since this is automatically opening while we already press. So we have to provide normally normally open contact of this contactor. Why? Because this open contact will serve as a holding contact of the start push button. So we have to parallel it with it. So when we press the start, the contactor will energize and the normally open contact will close. So later you will see. And this stop push button will serve as stop only. Okay. This run button is will only connect here as parallel with okay, and then the other one is here. This normally close is the normally close contact of MC, or the main motor contactor. So we'll install it in series with this stop pilot light. Okay, that's that. So we have to provide a color for this. Let's say the color of the the stop pilot light is red, and the run pilot light is green. Okay, and this one, the 3 pilot light, will be yellow. Where do we connect this? So we will connect this here. Okay, where do we connect the 3 pilot light? This is connected on the other the line, the neutral, and the other one is here in parallel as well. But we will provide normally closed contact here, connected with the overload relay, assuming that we have overload relay here. So let's provide overload relay. This one will serve as overload relay. Okay, but there's no tripping device here, so okay, let's install it in series, assuming this is the overload relay, OLR. Okay, so we have to install a normally closed contact here. So this is normally closed contact of this overload relay. Okay, so when this overload relay trip, it will open, so the trip light will glow. Okay, will glow, will lit, or whatever. Okay, given this diagram, we can now start the motor. Let's try. So how? This is the 3-phase motor, and then so when we press this run button, the stop button is already glowing the red, since we temporarily install overload relay the same with the contactor, so the trip light is also glowing. So when we press this start button, let's try, you will notice that this start button will not stuck on the closed position. The only purpose of this start button is to supply current from here directly to MC. Then when the MC is energized, you will notice that this normally open contact will become closed. So let's start. Oh, only one relay or motor must be connected on this connection, so it's wrong. We'll try to install this OLR in parallel. Okay, since that is in series contactor, so contactor will be, let's try to install it in parallel as serve as okay, OLR. Okay, this one is OLR. Okay, start again. When I press, you will notice that these two lights will given that diagram, we can prove that the motor, three-phase motor, will start according to that connection. You will see the run button, the run pilot light is lighting now, the glowing now. This is green. So when you press stop, you will see that this is stop light will lit, and the trip will lit as well, because this OLR is the same with the contactor. We don't have OLR on the components. So let's press stop. Okay, so there is still a current flowing here to here, signifying that the contactor is not energized. So our motor is stop as well. The contacts here is open. Let's try to insert tripping device here on the overload. This overload is DIY. So let's try to insert stop button, so it will open the OLR. Okay. Okay, assuming this is the trip button. Right. Okay, let's try. This is a DIY only. Let's try if it will works. Okay. Okay, let's press start. This should not be I think we have wrong connection with the trip pilot light. Let's see here. Okay. Okay, the trip pilot light will only lit if the overload relay will trip. Okay, so the overload is connected on the normally open of this. Okay, probably we are wrong here. So okay, let's install normally open here. Oh no, this is not. Let's install normally open. Okay, this one. Okay. Here, trip. Okay. this button, okay, let's start. Okay, this one is wrong. This should be normally closed. Let's provide normally closed contact. The previous one is correct. So OLR. Okay. You'll notice here the trip light is connected on the normally open of overload. So the normally open of the overload, this is one. This should be normally open. So when you press here, this one will become open. This one should be open when you press the overload. Since this is contactor type, we can de-energize the OLR. Okay, let's try to press start. Since this three-phase motor is already running, okay, and then we have installed this OLR and trip button as a DIY since we have no overload relay on these components. Let's try if this trip light will glow. So when we assuming that there are faults or there is faults on the load on the three-phase motor, so the trip button should stop the motor. So I think we have forgotten another normally close contact series with this to stop the motor. So when we press this strip, you will notice that this light will glow. Okay, that's right. Okay, you will notice that the light is glow, but the motor is still running. So we have to insert another normally close contact in series with the contactor so the motor will stop. Okay, let's try. So from that we will insert normally close contact here, so to stop the flow of current going to the main contactor. Okay, think here, since this is here. This one is the normally of overload relay. Okay, this one let's directly connect here. This strip button will open this all overload relay normally close contacts. Okay, let's try to normally open contact insert here, so we have a better simulation. Okay, this is the trip. I think this one is normally open. Let's try to explore the different components of this particular software, so we are aware and every aspect of these electrical controls. Okay, let's try to explore. It's a matter of simulation, so when we explore different components of this particular software, we can understand how it works. Okay, so this is the normally open. Assuming this is the normally open of that overload relay, it will not close until the overload relay is energized, right? So let's try to play. This contact have no relays. Oh, we have a spare here, so let's remove it. Okay, run. So I think we already get the concept by this simulation. So the system is the oh, I just realized it. This green button, play button or run button, is serve as the circuit breaker of the system. So when we press this one, you will notice that the current is flowing from this line going to this line, to the neutral. So you will notice that the stop pilot light is glowing, right? So let's start it using this push button. Let's click here. Okay, you will notice that the motor is running now, and the pilot light, green pilot light, is lighting as well. So this is green in color, but you will see it is dark, so dark, like it's almost black. Okay, when we press this trip button, you will notice that the trip will, when you press this should light. Okay, that's right. Oh, there's a wrong in another connection. When we press this trip, there should be a holding contact here, so it will remain normally closed. So I think we have a wrong connection in this overload relay. It should be let's proceed on the diagram. So the overload relay trip is connected on the neutral and then connected on the trip. So there's a continuous flowing current here from line 1 going to trip. Okay, let's make it work. So you will notice this is connected on the, let's stop the turn off the breaker. So let's remove it here. Let's try to connect it directly here on the line side. Okay, let's turn on the breaker again. Okay, for now the pilot light is stopped because we did not yet push the start button. So when we press this, the motor will run. Okay, this one. Okay, you will notice this is running. The motor contactor, normally open contact, became closed because this contactor is energized. Okay, the running pilot light is also lighting, but you will notice the MC, or the normally closed contact of the contactor, is become open because this is energized as well. So the overload relay is not yet tripping, so the trip pilot light is not lighting, and the open contact will not become closed unless this trip button will trip. Okay, assuming that there is a fault on the motor side or the load side, it's either line-to-line fault, overload, or whatever that triggers the trip button of the overload relay. There's a overload, so the amperage rating of this trip or overload relay has triggered, or the ampere of the load exceed the rating or the setting of the overload, it will trip now. So assuming that happened, so we'll try to trip the overload. When we press this trip button, this trip light should light. Okay, let's try. Oh, since the trip light is okay, when we press this, stop and trip will light. Okay, assuming that the trip is still intact, you will notice that these both lights will lighting, signifying that there is a fault on the system. So when we reset this trip button of the overload relay, the trip will off, the trip light will off. Okay, that's the basic concept of the DOL starter, or direct online starter, for the 3-phase motor. Thank you for watching.